All right, so look, I get it. You're a web developer. Your entire world probably revolves around REST, JSON, maybe you're even dabbling in GraphQL. And you know what? It works. It's fine. So why on earth should you care about something called gRPC? Well, here's the deal. gRPC isn't just some back-end stuff anymore. This is the secret sauce, the engine that powers these massive microservice setups at places like Google and Netflix. And the big news, it's finally ready for your browser. So if you care at all about performance, real-time data, or writing APIs that just don't break, you're going to want to stick around for this.
Okay, let's get one thing straight right off the bat. This is not a REST is dead talk. Not at all. REST is fantastic for a ton of things. This is about adding a new, specialized, super high-performance tool to your toolbox. Because sticking only to REST for everything, it's kind of like trying to build a modern real-time chat app by just hammering a JSON endpoint every single second. I mean, sure, you can do it, but man, there is a much, much better way. So here's probably the best analogy I've heard for this. Think of REST like walking into a restaurant and ordering from a menu in plain English. It's universal, everyone understands it, it's human readable, it works. gRPC, on the other hand, is like having a direct fiber optic link straight to the kitchen. You're not using descriptive words, you're sending these super compressed, pre-agreed upon codes that the kitchen understands instantly. The end result is the same, right? You get your food, but the communication itself is just unbelievably fast and efficient. Okay, so let's dig into why this should matter to you, a web dev, right now. Because for years, gRPC was kind of the secret language just for back-end microservices, locked away in the data center. But that wall, it's not just coming down, it's been totally demolished. So what is this thing, really? Well, at its heart, gRPC is a remote procedure call framework. Fancy name, simple idea, calling a function on a server as if it were right there in your own code. It was born inside Google to handle their insane scale. Now it's a huge open source project. And the two key ingredients, the things that give it its superpowers, are protocol buffers, we'll just call them protobuf, and the HTTP/2 protocol. I love this way of thinking about it. If you're a web developer who loves TypeScript for the safety and sanity it brings to your code, you are going to get gRPC immediately. It's basically TypeScript for your APIs. It creates this rigid, unbreakable contract between the client and the server. And what that does is it shifts all that potential complexity and error checking away from runtime, where things break in front of real users, and moves it to build time, where your compiler can catch the dumb mistakes before they ever ship. All right, let's talk about the first big pillar of gRPC's performance, protobuf. This is where we wave goodbye to the kind of chatty, human-readable world of JSON and dive headfirst into the hyper-efficient world of binary. I mean, look at this. This slide says it all, right? On the left, you've got your standard JSON object. Notice how we're sending the keys ID and name as strings with every single request. Now look at the right. That's the protobuf version. Yeah, it's just binary gobbledygook. It's not for you to read, but the important part is what's missing. Those descriptive keys are gone, replaced by simple numeric tags. So why does this matter? Well, you're literally stripping out all the repetitive, bulky, unnecessary data from the payload itself. And that difference translates to a massive difference in size. That simple little JSON object, that's about 30 bytes. The protobuf version, like 9 bytes. That is a whopping 70% reduction on a tiny little object. Now, just imagine a really complex payload and imagine thousands of API calls per second. This isn't just tweaking or optimizing anymore. You are literally slashing your data transfer costs, and more importantly, you're delivering a way faster experience, especially for your users who might be on a spotty mobile connection. But it's not just about the network savings, not even close. Because protobuf has a predefined schema, your server knows exactly what to expect. There's no guesswork, no parsing a big long string of text, and that means parsing it is just blazing fast. We're talking 5 to 10 times faster than parsing JSON. For your backend, that means way less CPU load. And what does that mean? It means you can handle way more requests on the exact same hardware, which ultimately just lowers your server costs. It's a win-win. Okay, let's talk about that second pillar of power, HTTP/2. You might remember the old way, HTTP/1.1. Your browser had to open up like 6, 8, a whole bunch of separate connections to your server just to get a few things. It was clunky, inefficient. Well, gRPC is built from the ground up on HTTP/2, which gives us this magic called multiplexing. It just means all your requests and all your responses, even for totally different things, can all flow at the same time over one single persistent connection. For latency, this is an absolute game changer.
So, okay, gRPC is smaller, it's faster, that's cool. But this is where its real superpower lies, in how it communicates. See, REST is pretty much stuck in that one request, one response model. gRPC, it gives you 4 totally different patterns, and 3 of them are basically custom built for the modern real-time web.
First up, you've got what's called unary RPC, and this is the one you already know and love. Client sends one request, server sends back one response. Done. It's your bread and butter, basically just like a classic REST call.
Okay, now things start to get really cool. With server streaming, your client sends just one single request, but the server can send back a whole stream of messages over time. Think of a live stock ticker or a real-time social media feed. Instead of your app constantly asking anything new, the server just pushes updates down the pipe as soon as they happen. It's kind of like server send events, but with all that type safety we talked about, basically SSE on steroids.
And of course, we can flip that completely on its head with client streaming. This time, the client sends a stream of messages up to the server, and then the server sends back just one response when it's all done. This is absolutely perfect for stuff like uploading a huge file in little chunks, or maybe sending a continuous stream of logs or telemetry data from your app.
And finally, we get to the holy grail, bidirectional streaming, or BIDI streaming. Here, both the client and the server can just send messages back and forth whenever they want, all over that single connection. It's a real, continuous, two-way conversation. This is the foundation for pretty much any modern real-time feature you can think of. Live chat, collaborative Google Docs-style editing, multiplayer gaming, you name it. And yeah, you could try to do this with WebSockets, but gRPC just hands you all the structure, the performance, and that awesome code generation right out of the box.
Okay, I can hear you thinking it. This all sounds great, but it's back-end theory. I live in the browser. And you're right. For a long time, there was a major technical roadblock. But that problem is now officially solved, thanks to something called gRPC-Web.
So here's the deal. For some really technical reasons, browsers just can't speak native gRPC. They don't have the low-level control needed. So the solution is the small, super lightweight proxy, like Envoy. Think of it as a translator. Your browser app speaks gRPC-Web to the proxy translates it, and then speaks native gRPC to your backend server. It's a totally seamless process that unlocks all this incredible power for your front-end code. And this isn't some abstract theory. This is what the actual code looks like in your app. Check it out. You import a client that was automatically generated for you from your API definition. That means no more handwriting fetch requests and then crossing your fingers, hoping you got the shape of the response object right. You just call a method like client.chat, and you get a fully typed stream back. Your IDE knows all the methods, it knows all the properties on the replies. It's just so clean, it's type safe, and it literally eliminates an entire class of runtime bugs. And look, this isn't some weird experimental tech that might disappear next year. This is battle-tested, production-proven infrastructure. We're talking about Google, Square, Netflix. They are all running gRPC and gRPC-Web at absolutely massive scale to power the very applications you probably use every single day. So, with all this power at your fingertips, the big question is, when should you actually reach for this tool? Because it's definitely not the right fit for everything. So let's get practical and break it down. Okay, so where does it shine? You absolutely want to use gRPC for internal microservice communication. That is its home turf. It is a complete no-brainer for any real-time streaming features, for performance-critical apps where every single millisecond counts, and for mobile apps where you're worried about bandwidth and battery life. It's also amazing for teams where you have services written in a bunch of different languages. Now, where should you skip it? Well, for just simple CRUD apps, REST is honestly way simpler. Don't over-engineer it. It's also probably not the best choice for public-facing APIs because other developers are just going to expect standard REST or GraphQL. And be honest with yourself. If you're a small team, there is a learning curve, so just be mindful of that. All right, let's boil this all down. If you walk away with just 3 things, make it these. First, gRPC equals protobuf plus HTTP/2, which means smaller, faster, and strongly typed APIs. Second, it unlocks 4 powerful ways to communicate, including all that real-time streaming that REST just can't touch. And third, and this is the big one, with gRPC-Web, this incredible power is available to you in the browser right now. So I really want to turn this over to you. For all the web devs out there who've heard about gRPC, maybe been a little curious, but haven't actually tried it on a web project, what stopped you? What's been the biggest hurdle? Was it the learning curve, the whole proxy setup thing, or something else entirely? Let me know down in the comments. Thanks for watching. I'll catch you in the next one.